average information content. Average information content and if you take the individual symbols, it is information content. If you want to know the content that is conveyed by the entire source, we have to go for the entropy, which is called as the average information source. It is nothing but probability of that particular symbol and content of that particular symbol. So P of xi into I of xi. So if you have n symbols, so we need to take the summation. That is all the terms mean we need to take. So therefore summation I is equal to 1 to m P of xi into I of xi. Already we know that what is I of xi? Log base 1 by P of xi. So with that equation we can calculate entropy. Then information rate is nothing but how much amount of information we are transmitting over the channel. Okay, what amount of information we are carrying over the channel is nothing but information rate. So how the information rate will be known? So what extent, so how many number of symbols we are converting per unit time or per time into what is the amount of information it is conveying. So that's why capital R is nothing but small r into h of x. So up to that extent we have calculated. Then we gone for the source coding. Source coding is nothing but, so we need now, till now we said that the information is set of symbols and I of x1 and the respective probability only we have calculated the information content. Now we need to calculate, we need to convert this particular information into zeros and ones. So as we know that few codes, how we can convert a particular number into zeros and ones. For example, we can go for 8421 code or else BCD code. Those are the examples codes. We can convert a particular number into binary. So similarly, but in the communication system, we can't say that every time those information is a decimal information. Any information will be there. So that's why we are calculating the binary code with respect to the probability. That's why it is called as a entropy coding, or we can call it as a source coding. So we are having two types of coding. One is Shannon-Fano coding and the one is Huffman coding. So first we will go for Shannon-Fano coding. So better all of you take your pen and notebook along with you and note the problem. Then we'll start simultaneously doing, all of you. And at the end of the class, I'll ask you to make the video on and I'll ask you to show the things what you have solved till now. Clear? I'll ask you whomever to make the video on, they have to show the problem up to what extent they have solved. Okay, clear? Okay.
Okay, ma'am.
Okay, then take your pen and your notebook and write on the question. Let the source has 6 source symbols. Let the source has 6 source symbols with probabilities 0.3, 0.3, 0.25, 0.2, 0.12, 0.08, 0.05. Okay. Obtain the full stop. Obtain the Shannon-Fano coding and efficiency. Obtain the Shannon-Fano coding and efficiency. Clear, ma? Yeah. How many probabilities is given there? How many symbols are there? 6 symbols. And how many probabilities is there? 6 probabilities. So in any of the coding, the first step is list the probabilities in higher number to lower number. Okay. So if most of the time the probabilities will be given in higher to lower, but certain times it might be jumbled also. At that case, what you are supposed to do, first you have to list the probabilities in an order of higher number to lower number. Clear? The first step is listing of all the given probabilities of the source symbols from higher number to lower number. And if you observe what are might be the number of source symbols, the entire probability will be always 1. Okay, the total probability will is only 1 or not. Okay, so therefore if it is a 6 symbols, it is 1. If it is 20 symbols also, the probability will be always 1. You have to keep in mind that all the total, all the probability total must and should be equal to 1. So no need to check. Obviously it will be 1. If you want to cross check, if you take any problem, the total probability summation will be 1. If you check here also, it is 0 0.35, 0 0.55, here 2, then 0 0.75. If you add these to 0 0.25, totally the probability is 1. Yes or not? Is it correct, ma'am? Whether all the probabilities are getting 1 or not? Okay. If you say okay, then I'll move for the next step. Okay.
Okay, ma'am.
Okay, first, have you listed all your probabilities from higher number to lower number? Have you written?
Yes, ma'am.
Okay, then.
Ma'am.
As we said that the total probability is 1. So here it is a first set, only one set. So it is a partition algorithm. That is, we are going to divide this probability set into parts. Okay, so then how you will divide? Generally, we need to divide equally, yes or not? But all the time we may not get equally. Certain times we may get certain, sometime more or sometime less. So that can be excused here also. So if you take the entire probability, if you take first two, it is 0.55. We are not getting exactly 0.5. So therefore the first two is 0.5 and the rest is 0.45. Yes or not? So take it as a granted. Okay, divide this into two sets. The first is upper probability and the below one is a lower probability. So therefore the first set is divided into equally probables. More or less it might be nearer. So certain times we may take exactly 0.5, 0.5. Certain times it may get 0.55, 0.45. If you take reverse also, if things comes over. If we are having 0.45 and below 0.55 also, it can be taken over. Okay. Certain times we will get 0.6 and 0.4. But all the time we are listing from higher number to lower number, the upper probability should be always greater than the below one. Yes or not? So manaku paina takku vache chance undadu. Upper set will be always a lower probability. It might be 0.5, 0.55, 0.6 also it can be granted. Okay. Then lower will be 0.4. Here it is 0.55, 0.45. Keep in mind the upper set probability should be assigned with 0. And the rest, the lower set probability should be assigned with 1. The second step is you need to partition the total probability into two equally or nearly equal probabilities. That is second step. Okay, then the third step is assign 0 for the upper probability set and 1 for the lower probability set. That is third step. Okay, clear? How we have in the step 1 we have written zeros for this upper set and the remaining is 1 1. Okay, ma? Clear? First step is clear. Clear, or if you want me to explain, I'll explain. Shall I move?
Yes, ma'am.
Okay. So first step is upper probability 0 and lower. This step will be continued until there is no further partition is there. The same procedure we need to adapt for the next further also. Until there is no partition existence, we need to continue. This is the algorithm. If you want to write in a theory, this is the steps you are supposed to write. Then coming to the problem. So then again, if we say having two sets, what we need to do? Again it should be partitioned. Okay, here we are having again 0.3 and 0.25. Again this can be divided into two sets or not? Again it is nearer to each other or not? So again the upper set is divided into 2 halves. Again upper will be assigned with 0 and lower one will be assigned with 1. Clear? Is it okay? The upper set is assigned with again 0 and 1. Here the first set is again subdivided into 2 more. So therefore no further partition here. Then coming to the lower set. If you observe this here, it is 0.2 and the rest is 0.25. Okay. Then if we can divide into again 2 halves, 0.2 and 0.25. Upper set is 0 and lower set should be 1. So therefore it is come. Then we need to divide these 3 into 2 sets. Again it is 0.2 and below one is 0.13. So therefore we can get 0 and the remaining is 1, 1. Again if we divide 0, 1. Okay. And finally we are going to write the combining of the bits that were respective to